Okay, so at the end of the worksheet yesterday, this would be a typical question. It involves reflections, which was the new topic. It involves a parent function that you know. Hopefully you knew this was the absolute value function. And it also involves, it got moved. So let's see. Did you say absolute value of x, except it got moved to the right 5? How do you do that? Minus 5. And it got flipped up and down. Is that a vertical flip or was that a horizontal flip? That was a vertical flip because it used to be here. And how do you do that? Vertical, high-vo. Horizontals are on the inside. Vertical stuff is on the outside. That's a vertical flip, so it's a negative out there. And then one more little thing. It also got moved where? Down 1, minus 1. You need all those parts right. Did anybody pull that one off? Ooh, a lot of people. More than half, actually. All right, I'm going to give you one more. Ready? Let's say I take that square root and I move it to over here and it's flipped. So there's my square root function. And I should really, and you can ask me on tests too, like, should that have an arrow on the end of it? Yeah, it should. This end does not have an arrow. It doesn't go forever in that direction. Can you write me the equation for that? What I found on tests is that these are the ones that are the most challenging for kids. Here's a picture, you tell me the equation. Did you say that it was a square root of x to start with? How many had that part right? Okay, then tell me more. Tell me something you know. It's going to the left 6. So how do I do that? Plus 6 is correct. Raise your hand if you had that part right. Okay, good. Question? Or were you giving me an answer? Okay, why don't you finish it up? Tell me the answer. Horizontal reflection. Because horizontals are on the inside, like the high-vo thing. And then vertical on the outside. Okay, so it's a horizontal, so I'm putting the negative in here and parentheses. If you forgot the parentheses, you just got it wrong. And it's not just because I'm being picky. It's different. Think about it. If I put that parenthesis on it, do you get that the negative could be distributed out and therefore be a different answer than if it doesn't have parentheses? And only one of them actually works. If you actually use your calculator and type it in, only this one with the parentheses would be right. The other one wouldn't work. And I know you're thinking, but here's why. If you move it first and then flip it, you get a different answer than if you flip it and then move it. Okay? So it makes a difference whether you have those parentheses or not. It does. All right. I'll give you one last proof that the parentheses matter. Square root of negative x plus 6, that's what I said it was. Okay? And here's an option that's different. I know some kids think that's right. Let me just prove to you by sticking in a number and showing you you're going to get a different thing. If I stick in x is, well, we know that this point is supposed to work, right? So if I stick in negative 6 for x and see what happens, right? If I put in a negative 6 here, and I put in a negative 6 here, I get two different answers? This one would come out to 0. Ooh, that's what it does come out to, see? That's the right one. This one would come out to positive 6 plus 6, which would be square root of 12. The point is not negative 6 comma the square root of 12. The point is negative 6 comma 0. So that way it worked with the parentheses. Proof. You have to have the parentheses, otherwise it won't work. All right. So that's a quick review of the toughest part of yesterday. So what's new for today? Not too much, thankfully. I'm going to show you a few things about how to write some equations, and I'm going to ask you to find the file for today. It's got today's date on it, and we'll pull that up next. Okay, so here we go. On this worksheet, the first thing they want you to do is take the words that they say and make it into an equation. So they say this is how you start. Y equals, and if I were you, I'd leave some room around the x, because you're probably going to like be moving it to the right or flipping it or moving it down or whatever. And I know you can always erase it if you have to. I'm just trying to save you some time. And then if you put a little parenthesis, I'll make sure it's clear where the inside versus the outside is. Okay, next. It says that this guy's reflected over the x-axis. Now, that, you need to get straight which one's which. You get this is the y-axis, and this is the x-axis. And so if you're flipping over the x-axis, is what I just drew a vertical, that red thing that was flipping, was that vertical or horizontal? That was vertical. So over the x-axis, vertical. And then you got to figure out, where does that go then? Well, if you have the HHA thing memorized, you know that it's vertical on the outside, that can be on the front or the back, and horizontal on the inside. So now I ask you, where should I put the negative if it's supposed to be reflected over the x on the outside? So you could try to memorize this as over the x-axis is on the outside. But there's a lot of things to memorize about this, and I don't know if that's worth memorizing. The HHA thing is definitely worth memorizing. And then you can just figure out, is it vertical or horizontal when you go across the x? All right. And then translated down 5, that's easy. Down 5 is like that, minus 5. Okay, that's writing an equation. Not that hard. You just got to start with the base equation, like y equals 1 over x, and then figure out where to put the changes, like the negative and that kind of stuff. Now, I want to talk about this one for just a second, because here's one that drives kids a little crazy. Okay, let's say that I put the negative on this thing, and I'll hear like two kids talking, and one of them says, well, you got to put it on the inside because of this. And then the other kid will say, no, you got to put it on the outside. And then the kid will say, but the negative on the outside is the exact same as putting the negative on the inside. Like, negative 1/3 is the exact same thing as 1 over negative 3, isn't it? Well, that's a pretty good argument. It's because with the 1 over x function, I want to show it to you. Here's why they're both right. This is what 1 over x looks like in the first place. This is the one where if you flip it the one way or you flip it the other way, it comes out exactly the same. So it doesn't matter if you put it on the inside or the outside, because a negative 1/3 or a 1 over negative 3 is the same. So it won't matter if you put it inside or outside. It's the only function like that. Watch, if I flip it horizontally, that's going across this way, it looks like this blue one. And guess what? If I flip it vertically, it would look like the blue one. They're identical. It's the only function where a left-right and an up-down are identical. It's the only one of the 5 that you know. There's other functions in the world, but of the 5 you know, it's the only one where an inside or an outside reflect do the same thing. And it's because on a fraction, it doesn't matter if the negative's here or if the negative's down there. Doesn't matter. Yes?
If we only have the negative 1 over x, but if we don't.
Okay, so wait. I'm going to answer this one for you. I'm going to say, since it's over the y-axis, that's a horizontal thing. I would like it on the inside, but could I mark it wrong if it was on the outside? No, it does the same thing. And now you asked about parentheses. You tell me. Do you think if I put this in parentheses, it's going to actually make any difference? It's actually not. But if I had to move it to the left or the right, then it would matter. Okay? So like if I right now needed to take this and move it to the right 7, then I'd want to go like this and use parentheses. But it's not a right 7, it's an up 7. So I don't need to do that. Let me get rid of that I just wrote. Because it's up 7, I just go like that. I don't have to worry about it. But if it had been on the inside, I'd need the parentheses. Math is picky. Math is like really exact. And I know some of you hate that, but there are times you need really exact. Do you get if you are making an iPhone and you got a guy who's your engineer and he's like, well, that's really close. It's close enough. You get that something isn't waterproof unless it seals like perfectly, the top and the bottom. You can't just be like really close. Water's going to get in if it isn't perfect. You know what I mean? So you can't just be close when you're making something like an iPhone or you're programming the iPhone. Do you think if they have literally one colon in the wrong place in the programming language, it doesn't work? And you get this bug, and then people are like, oh, my iPhone doesn't work, and then their stock goes down. And they're almost a $1 trillion company. So literally, one colon in the wrong place in the software could cause them to lose $100 million in stock value. Like if the iPhone X that's about to come out has a flaw in it, I guarantee you their stock's their value of their company is going to go down by 1%. If there's a flaw, something's wrong with the iPhone X, it'll be a huge deal. It'll go down at least 1%. It might go down 5%. And a company that's worth $1 trillion, you're talking like $100 million mistake. So my point is, don't tell me that oh, it's this class is stupid. If I did one negative wrong, I get the whole thing wrong. Yeah, well, we need people to be exact. That's what math is. You make a mistake on a negative, you're going to screw up the iPhone, so to speak. And are there jobs where you don't have to be exact? Yes. Brain surgery? Nah, you got to be pretty exact. If you go in there and just poke slightly the wrong place, you can I actually know a guy. He actually got nicer after brain surgery. And there's other people, I'm sure, that go the other way, get meaner after brain surgery. Okay, but I know a guy, and actually everybody likes him better now. Because I don't know what they did in there, but they poked something, and he's different now. All right. Don't worry, he doesn't listen to my videos, so it's fine. All right. Your homework for tonight is going to involve lots of negatives and parentheses and being careful. All right. So let's go through, and I can see if I can find a few that you don't have to do to make the assignment a little more reasonable time-wise. I do want you to do all the rest of those all the way up through E, because those are really important. Let's go to number 2. How is this any different? Now it gives you the equation, and it wants you to say what happened. Okay, you got to flip this, and you got to reflect it over the x-axis or whatever, and you got to move it down, and you got to move it to the right there. You got to describe it. Those are important too. I don't think we need to do all of those. I can skip D as in dog. One thing though, these when they're out in front, a lot of people get confused what they're doing out in front. Do you get if they're on the outside, it doesn't matter if it's here or there. It's the same thing. Don't let the number in the front freak you out. All right, so we're skipping D. Then we go down in here. We have way too many of these. You don't have to do that many of those. So let's do A, B, and C are all good. Let's skip D again. And I can even skip E. That'd be fine. Some kids ask, are there any extra problems I can do for extra practice? Well, when I skip problems like this, those are problems you could go back and do for extra practice if you wanted to. There's answer keys for it too. So, all right, that'll cut your assignment down to a little more reasonable size. Let's look at one of these. You may notice that A, B, C, D, E, and F all start with the same exact thing. Does that mean the question is the exact same? No, you want to move that somewhere based on what it says. That's asking you to do what kind of a reflection. Is that a vertical or a horizontal reflection? Do the high-vo thing. Vertical. That's a vertical reflect. Which way is vertical? Vertical's up and down. Therefore, it's across the x-axis. Now, I hope this isn't too tough for you. There it is. Vertical reflect. All right. So, I think that's a pretty reasonably sized assignment. Now, you're going to get a bunch of work time. During that work time, I want each of you to look over the top 20, and if there's anything that you still are not feeling like you get, during your work time, I'm going to challenge you to come up and ask me a question. You don't have to. I'm not going to make you. But I would love it if everybody in here, unless you think you've got them all, would come up and ask me a question on that. You don't have to. But I think it would be good for you. One kid asked me, he made me teach him 7 of them last hour. Okay? I'm willing to do that, except I can't. I want to try to touch everybody like once, but if you don't feel like you need the help, it's totally okay. But if you know there's one that's been bothering you and you never seem to get them right, show it to me on the top 20. You got a hot link to that on your iPad. Just one touch. Should be able to find the top 20 really quick. Let me teach you something during work time. All right. That's all I got for you for today's video.